Good day to our respected lecturer and my fellow friends. Today, our group will be presenting our project titled The Role of Biogas Technology in Environmental Sustainability and Socio-Economic Development in Malaysia. Before we proceed, let me introduce myself. My name is Amdamia binti Samsul Bahadi and my metric number is F24A1243. For the first part of this presentation, I will be covering the introduction, problem statement, and also technology description of our project. Let us begin with the introduction. Biogas is a clean and renewable energy source driven by highly specialized microbial networks during anaerobic digestion. In the Malaysian agro-industrial context, our palm oil sector is a massive economic powerhouse. However, it concurrently generates millions of tons of palm oil meal effluent or POM annually. This is where the biogas solution comes in. It successfully mitigates severe industrial pollution while converting a hazardous agricultural liability into grid-ready green electricity. This brings us directly to the problem statement. The main challenge in Malaysia right now is our heavy reliance on traditional open lagoons to treat POM. Raw POM has an extremely high organic strength with BOD levels reaching up to 50,000 milligrams per liter. Left in open ponds, it releases massive uncaptured methane emissions directly into the atmosphere, contributing to global warming. Therefore, the scope of this project focuses specifically on enclosed pond to biogas technology in Malaysia. We will analyze the biological process, gas scrubbing systems, and its socio-economic impacts, all bounded within SEDA Malaysia's feed-in tariff regulatory frameworks. Moving on to the technology description, biogas technology involves the decomposition of organic waste inside a sealed container called a digester. This process occurs naturally through microbial activity under oxygen-free conditions. The unrefined raw biogas capture typically contains 50 to 70% methane, which serves as our primary combustible component for energy generation. It also contains 30 to 50% carbon dioxide and small trace impurities like hydrogen sulfide and water vapor. Now, let's look at how this biogas is produced. Step 1 is feedstock collection, where organic waste streams like POM, household food waste, and animal manure are gathered. Step 2 is digestion. The waste is placed into a airtight digester where bacteria break down the material through 4 biological phases. Hydrolysis. Bacteria release enzymes to break large organic matter in POM, like fats and proteins, into small water-soluble sugars. Acidogenesis. Acid-forming bacteria take this sugar and convert them into volatile organic acid and alcohols. For acetogenesis, another group of bacteria transforms this acid into acetic acid, hydrogen gas, and carbon dioxide. And lastly, methanogenesis. Finally, unique microbes called methanogens consume the acetic acid and hydrogen to produce actual methane gas. Once methanogenesis is complete, we move to step 3, biogas production. The trapped methane gas is collected and passed through purification system to strip away corrosive hydrogen sulfide. The clean gas is then utilized for electricity generation via gas engines, industrial heating, or cooking food. Finally, step 4 is digestate production. The leftover stabilized material at the bottom of the tank is highly rich in nutrients and is fully upcycled into organic fertilizer and soil conditioners, completely closing the loop of the circular economy.
To ensure our technical analysis matches real-world operations, let us look at the industrial process inside on this slide. First, under point 01 and 02 regarding pre-treatment, raw palm oil meat effluent discharged from the meat is extremely hot, reaching up to 90 degrees Celsius. Since anaerobic bacteria cannot survive in this extreme heat, it is mandatory to regulate the temperature down to an optimal 38 degrees Celsius in cooling ponds. This directly provides critical microbial protection to ensure the bacteria can digest waste efficiently. Next, under point 03 and 04 regarding gas purification, the unrefined Fine biogas collected cannot be fed directly into power generated because it contains a major gas corrosion hazard known as hydrogen sulfide. The facility must implement advanced gas scrubbers or filter system to completely strip away moisture and hydrogen sulfide. The biomethane upgrading path allows the mill to generate clean electricity safely without causing any mechanical damage to the heavy engines. Now, let us look at the socio-economic impact of biogas technology in Malaysia. As shown on the slide, this technology drives social and economic growth through two major pillars. The first pillar is job creation and rural growth. Under this, it provides localized employment by creating valuable engineering and plant maintenance jobs in rural agricultural hubs. It also promotes community empowerment by keeping technical knowledge and wealth within rural districts near oil palm estate, which result in income stabilization to buffer local population from volatile global commodity prices. The second pillar is energy autonomy and cost alleviation. Biogas technology supply decentralized power to fulfill local milling electricity and thermal demand on site. It is also achieves resources circularity by converting digested residue into nutrient-rich organic biofertilizer. This leads to input optimization by minimizing synthetic chemical fertilizer costs and enhancing agricultural supply chain margins. Next, let us move on to the environmental sustainability contribution of biogas technology. As shown on the slide, this technology acts as a major ecological solution across three pillars. The first pillar is climate change mitigation. By capturing methane from palm oil mill effluents through anaerobic digestion, we directly prevent large greenhouse gas emissions from entering the atmosphere and create a net negative carbon footprint where clean electricity successfully replaces fossil fuels. The second pillar is water resources protection. This biological treatment reduces the biochemical oxygen demand and chemical oxygen demand of raw palm oil mill effluents by over 85%. This mitigates critical threats like river pollution, eutrophication, and massive fish kills. Most importantly, it helped treated effluents meet strict Malaysian discharge standard of below 20 milligrams per litre of biochemical oxygen demand. The final pillar is circular economy and sustainable agriculture. The system upcycle organic waste into nutrient-rich digestate the serve as an eco-friendly biofertilizer, reducing our reliance on synthetic nitrogen and phosphorus fertilizers while improving long-term soil health.
Next, I will explain how biogas technology is being implemented in Malaysia. Malaysia has strong potential for biogas development because the country produces a large amount of organic waste from agricultural, livestock farming and food processing industries. The most important source is the palm oil industry. Palm oil mills generate a liquid waste called palm oil meal effluent or POME, which contain a high amount of organic matter. Through anaerobic digestion, this waste can be converted into biogas instead of being released into the environment. Many palm oil mills in Malaysia have installed biogas capture system. The biogas produced is used to generate electricity, provide heat for industrial operation or be supplied to the grid. Beside the palm oil sector, biogas systems are being used in livestock farm to process animal manure and in some municipal waste management projects. The Malaysian government has supported this development through policies such as the Renewable Energy Act 2011, the Feed-in Tariff Scheme and the National Energy Transition Roadmap. This initiative encourages industry to invest in renewable energy technologies including biogas. However, several challenges remain. The initial installation cost is relatively high, skilled technical management is required, and awareness among some stakeholders is still limited. Despite these challenges, the implementation of biogas technology continues to grow and plays an increasingly important role in Malaysia's transition towards cleaner and more sustainable energy.
Hi everyone, today I would like to highlight how biogas technology acts as a powerful catalyst in achievement the United Nations Sustainable Development Goals (SDGs) in Malaysia. First, SDG 7 Clean Energy. Biogas convert agriculture waste into a stable, continuous sources of renewable baseload power. This direct reduce our national dependency on depleting fossil fuel. Second is SDG 30 Climate Action. By capturing methane emissions straight from agro waste, this technology play a crucial role in supporting Malaysia's national pledge to achieve net zero carbon emissions by the year 2050. Third, SDG 12 Sustainable Consumption. Biogas perfectly embraces the circular economy model. It recycles organic waste completely, ensure nothing goes to waste while producing high-quality organic fertilizer. And finally, SDG 8 designs work and economic growth. Beyond the environment, biogas create high-value technical and engineering jobs, bring economic growth and specialized skill directly to our rural community. Moving on to the next slides, we will look how we transition a theoretical biogas project into functional low-risk commercial reality. To achieve this, our framework relies on four essential pillars. First, technical infrastructure. We rely on detailed blueprint for anaerobic digester SCADA system for real-time methane monitoring and strict gas handling SOP to keep operations safe. Second, regulator complaints. All projects are strictly guided by SEDA and the Department of Environment. They enforce the safety code, grid connection standard, and influence discharge limit we must follow. Third, financial mechanism. To make this project economy viable, we leverage concrete final instrument like the Green Technology Financing Scheme (GTFS) and specialist tax incentive for MIDA. And finally, commercial reality. By combining this engineering manual, policy handbook, and financial template, we successfully transition a theoretical project into a functional, low-risk commercial operation. Thank you.
To conclude, biogas technology offers a practical solution for addressing two major challenges at the same time, which are waste management and energy production. In Malaysia, abundant organic waste from palm oil mills, livestock farms, and food industry provide a valuable resource for biogas generation. By converting this waste into renewable energy, biogas technology helps reduce greenhouse gas emission, minimize environmental pollution, and support the circular economy. Beyond environmental benefit, biogas also contributes to socio-economic development. It can reduce energy costs, create employment opportunities, improve rural energy access, and produce organic fertilizer that supports agriculture. These advantages show that biogas is not only an environmental technology but also an economic opportunity. Malaysia has already made progress through government policies and industry initiatives, especially in the palm oil sector. Nevertheless, continued investment, technical support, and public awareness are needed to expand biogas adoption nationwide. Overall, biogas technology demonstrates how renewable energy can support environmental sustainability while improving economic and social well-being. It is an important step toward a greener and more sustainable future for Malaysia. Finally, I would like to show our personal reflection and pledge regarding this topic. Through this project, we have gained a deeper understanding of how biogas technology can transform organic waste into a valuable source of renewable energy. We learned that biogas is not only beneficial for the environment but also contributes to economic growth and community development. This has shown us that sustainable technology can play an important role in addressing real-world challenges such as waste management, energy security, and climate change. This topic has also increased our awareness of the importance of adopting renewable energy solutions and making better use of available resources. It reminds us that waste should not always be viewed as a problem, but as a potential resource that can create positive impacts for society and the environment. As our pledge, we commit to supporting sustainable waste management practices, promoting awareness of renewable energy technologies, and encouraging environmentally responsible action in our daily lives. We believe that even small efforts can contribute to cleaner, greener, and more sustainable future for Malaysia. Thank you.